Okay, so these notes are going to be about functions. So first we're going to talk about what a function is, what the definition of a function is. So there is a fancy definition that says a relation where every input or x has exactly one output. So every x has one y. So we're going to write it in abbreviated terms. So I'm going to write every x has one y. So where every x has one y term. And then just another way, and maybe an even simpler way to think about it, is that no x value can repeat. So no x can be in an ordered pair twice, or on a coordinate plane twice, or on the graph twice. So we'll look at some examples here in just a second. So no x repeats. So a function is when no x value repeats. So that's really important. It is when no x value repeats is a function. All right, so to test whether a relation is a function, when you're given ordered pairs, you just look at the x's. So you're just looking to see, do any of the x's repeat? If they do, then it is not a function. So really important first that you remember in an ordered pair that the x comes first, then the y. So we will always want to look to see, is that x value repeating? So we're looking at the x's to see if they're repeating. Okay. Given a graph, we use what's called the vertical line test. So it says if a vertical line intersects a graph more than once, then it's not a function. So you'll see an example like that here in just a second. Okay, so the instructions then are just determine whether the following are functions. So all we're doing is we're looking at a set of ordered pairs, and so we want to identify the x's, and we just want to see, do any of them repeat? So if I look at this set of ordered pairs, we have an x of 3, an x of 2, an x of 0, and an x of -1. None of those repeat. They're all different, so this would be a function. So I'm just going to write here that this is a function. All right, so same steps, just looking at the next example. Again, we're identifying the x's. So we're looking at -2, 0, 2, and -2. So you should notice that that -2 right here at the beginning and right here at the end, those are the same x value. So the x value repeated, so this would not be a function. So I'm going to write not a function. And basically it's as easy as that. Just looking at the x's, did it repeat or did it not repeat? So looking at number 3, we have a table of values. Same steps. It's still kind of a set of ordered pairs. It's just written differently. So we're looking at our x's. We just look down the column here. So we have 3, -1, 0, 2, and 3. So you should notice we have a 3 here and a 3 here. Those repeated, so this would not be a function. Notice I haven't even looked at the y's. I don't really even care when we're talking about is it a function or is it not a function, what the y's are. That doesn't matter to me at all. All right, so looking at number 4, same thing. We're just looking at the x's. So I start here, -4, -2, 1, 2, 5. None of those are the same, so this would be a function. All right, so moving on to number 5 and 6. This is what's called a mapping. So a mapping just is basically a set of ordered pairs, or kind of like a table, but it's just a different way to display it. So the way you know if any of these x's repeat is if there's more than one line coming from any of the x values. The x is always on the left. So usually they will label it, but if they don't, just know that that's always the x on the left. So y would be on the right. So we're just looking, we have one line coming from -3 right there. We have one line coming from -1, one line coming from 2, and one line coming from 4. So none of those x's repeat, so that means that this is a function. And then same process for number 6. Notice the x and y here are labeled this time. Again, we only care about the x's. So we have one line coming from -4, and then when you get to -1, you notice it's going to the 0 and to the 7. So if I were writing that out as an ordered pair, it would be -1, 0, and the next one would be negative 1, 7. Oh, my bad. Negative 1, comma, 7. So that negative 1 repeats, so that makes this not a function. So not a function if x repeats. So this negative 1 right here is what made this not a function because it repeats. All right, so looking at the graphs then, this is where we're going to use the vertical line test. So we're going to look at the graph, and basically you're looking to see, is there anywhere that you could draw a vertical line that's going to cross more than one point? So if I look at number 7, I could draw a vertical line here that goes through only one point. Could draw a vertical line here that only goes through one point. But when I draw a vertical line right here, that goes through this point and this point. So it's crossing more than one point. So those x's are the same. If I wrote out those ordered pairs, this top one would be 1, 2, and this bottom one would be 1, negative 1. So again, those x's repeat. They're both a 1, so this would not be a function. So this is not a function. All right, number 8, same thing. We're just looking to see, is there anywhere that I could draw a line that it's going to cross more than one time? If it does, then it's not a function. So I have an ordered pair here. If I draw a line there, only crosses once. If I draw a line here, only crosses once. If I draw a line here, it only crosses once. And if I draw a line here, it only crosses once. So every single one of those x's is different. If you wanted, you could write out all the ordered pairs. That would be another way of doing it. So this x value at this ordered pair, the one on the far left, would be negative 1, 2, 3. The x value at this point, the next one, would be negative 2. The x value at this coordinate would be a positive 1. And the x value at the last coordinate farthest to the right would be 1, 2, 3, 4, 5. So every one of them has a different x. I didn't even need to identify what any of the y's were because, again, that doesn't matter. So this one is a function because none of those x's repeated. All right, so 9 is a little bit different. This time we have a funky looking graph, something you've probably never seen in Algebra 1. But again, all we're looking for is there anywhere you could draw a vertical line that it would cross more than one time? And if you look at this arrow here at the end means that's going to keep going, and the arrow here at the other end means that is also going to keep going. So there is no place here that you could draw a vertical line. We could try. If I draw a vertical line there, touches one time right there. If I draw a vertical line here, one time. Draw a vertical line, one time. No x value on this graph is the same as the point right before or right after it or at the other end of the graph. So this is a function. Okay. And then number 10, same type of question. We have a graph, again, one you probably haven't seen in Algebra 1 or in 8th grade, but again, we're just looking, is there any place I could draw a vertical line that it would cross more than one time? Or is there any place that has the same x value as another coordinate? So if you start down here, you might think, no, that would not happen. But if you get to here, you should see that that point and that point are going to have the same x value. Both of those have an x value of negative 1. The same for here and here. Those lie on the same vertical line. Here and here, those lie on the same vertical line. So this one is not a function. Some of those points have the same x value. So not a function. And that is it. That's all you need to know really for what a function is. So hopefully that's pretty easy for you. So let's now talk about function notation. So function notation is just a different way that we can write an equation. So the instruction, or the top there says, equations can be written in a form called function notation. We use this as a quick way to evaluate functions for a given input. So the input is always going to be the x, right? Input is x. Y then would be the output, okay? So, for example, we have y equals 3x minus 4. Another way that we can write that is f parentheses x equals 3x minus 4. So we don't read that f parentheses x. We read that f of x. So f of x is what we're trying to write there. F of x equals 3x minus 4. So f of x, f parentheses x is f of x. Basically, all we did is we replaced the y with f of x. So that is really, really important that you understand that f of x is y. So f of x is the same thing as y. Okay. So the next section, to evaluate a function for a specific value, you substitute the value in for x. We're going to plug in the number for x. So let's look at this first example, and I'm going to get my calculator up too so you can see how I would do this. I would definitely, you don't have to use a calculator on some of them, but it gets a little more difficult, so I'm just going to show you how to do that. So number one, we have f of x equals x plus 7. So now they're asking us what is f of 5. So notice this was an x right here. Now it's a 5. So basically they're telling us put this 5 in for that x right there. So I'm going to just kind of draw an arrow. They replaced 5 with x, so we're going to replace this x with 5. So if I write that out, it would look like this. 5, every time I substitute a number in, I put it in parentheses. Even sometimes I don't need it, but I do it always. So 5 plus 7 would hopefully you know 5 plus 7 is 12. So if I'm doing that in my calculator, let me just show you, I would be typing in this right here for that x right there, 5 plus 7. So there's a few ways that your calculator can do this, and I get it, it's very simple and you don't really need a calculator, but it is important for the more difficult ones that you know how to do this. So the first way would just to be put parentheses 5 plus 7. Exactly like we wrote it, we get 12. So f of 5, I'm going to write that, f of 5 equals 12, because this right here equals 12. Okay. All right, so there's the first way to type it in. Another way would be to do x plus 7, and then we're going to tell our calculator we want to put a value in for x. So if you do control equals, and then this little vertical line, and I'm going to tell it when x equals 5, right? X equals 5, and I enter, it tells me, look, 12. So I want to know what is x plus 7 when x equals 5. So that vertical line will do that way. Okay. The third way I'm going to show you is to store a value. So we practiced this last week when we were solving equations. So I could do 5, and then I can store a value. So control, and then again this STO x. So now every time I push x, my calculator thinks it's a 5. So if I type in my problem here, x plus 7, it thinks I'm putting in a 5 instead. So if I type x plus 7, so notice how that x is bold because it knows, hey, she's putting that 5 right there in there. So x plus 7 is 12. So there's a third way to do it. I don't care which one of those you use, but I really would like to see you use your calculator. So let's look at the second one. We have f of -1. So we're using the same equation, the same f of x equals x plus 7, but now we're plugging in a -1. So again, if I'm writing it out by hand, which I'm going to, I'm going to put -1 in parentheses plus 7. So -1 plus 7, if you use your calculator, -1 plus 7, nope, maybe, -1 plus 7 is 6. Again, showing you one more time the several different ways. You could do parentheses, -1 plus 7, exactly like I just did. So -1 plus 7 like that. You could do x plus 7. That's actually going to be a problem because I already have a value stored for x. So I'm actually going to start over. So it is important for you to remember if you have a value already stored. So I'm going to type in this time x plus 7 because x is no longer stored. Notice it didn't turn bold that time. Control equals, and then my vertical bar. And this time I'm doing that for when x equals -1 because that right there is my x. So I'm going to say when x equals -1, enter. There it is. And then again, the third way, I can store -1 for x, so control, and then that STO store for x, and then I can type in x plus 7, because my calculator, see how it's bold, it thinks that's a -1. Okay, so there's that one. Okay, so I'm going to write that out. F of -1 equals 6. Okay. And then now we're going to do f of -3. So again, using my calculator to help me out, just make sure I get my answer right. I'm plugging in a -3 for the x right here, plus 7. So -3 plus 7, I can just type that in, -3 plus 7. I would usually use parentheses, but you'll see that the calculator just takes those away because you don't really need them. Okay, you can do x plus 7, again, is our equation. Control equals to get that vertical bar when x equals -3. There it is, 4 every time. So every time we get 4. Okay, so f of -3 equals 4. Okay. All right, so let's look at number 2. Number 2, we have g of x equals 3x minus 8. So they frequently will use f, g, or h to name those functions. So again, that letter is just like the name of it. That's saying we're using function g. Doesn't change anything except for that we're using a g instead of an f. Okay? So we're doing g of 1 for this equation, so we want to plug that 1 in for that x right there, and then we're going to plug in -3 for that x, and then 0 for the x. So same thing. So again, if I were writing this out, I would do 3, and then in parentheses on the first one, I'm plugging in a 1 for x minus 8. Okay, the second one, 3, and then in parentheses, I'm plugging in a -3. And then the last one, I would be 3 times 0 minus 8. Normally, you'll only do this one time. They wouldn't have you do 3 different values, but this was just for extra practice so we could get more problems in, but use the same equation. So again, we could just type these in. 3 times 1 minus 8 is -5. And then the second one, 3 times -3 minus 8. Here we go, -17. And then the last one, 3 times 0 minus 8, and then is -8. So I'm going to write those answers down. So the first one was -5, second one -17, third one -8. Okay. Again, if we write that out, it might at some point look like this. So g of 1 equals -5, because when we evaluated 1 in the function, we got -5. The second one would be g of -3 equals -17. And the last one, g of 0 equals -8. Okay, so again, using my calculator, the several different ways. So I'm going to do the second way. So I type in the equation. I don't have anything stored for x, so that's really important. To unstore, if you have anything, you can just open a new document, add a calculator. So I would just type in 3x minus 8, control equals to get the vertical bar, and I'm plugging in a 1 for x. So when x equals 1, that's -5, exactly what we got. I can scroll up and just highlight that and push enter, and it brings that all down again. And this time I'm going to change my x from a 1 to a -3, because the second time I did it when x was -3, -17. Scroll up and highlight. Again, I'm going to change that -3 to a 0. So delete 0. There we go. So there are the 3 different answers using that second method I was showing you. All right, so number 3 looks a little more complicated, so definitely please use your calculator on this one. There's no need to do that by hand. If you want to try it by hand, great, but please check your answer using your calculator. Okay. So on the first one, we're plugging in a -3, the second one a 0, and the third one a 9. Again, all of those are going in for the x right here. So this x right here is being replaced with those 3 numbers. So I would probably just do a new document. I would add a calculator, and I'm going to type in 2/3. So again, to get a fraction bar, control, which I already pushed, and then divide. 2/3 x minus 1. Now I want to evaluate that. So control equals to get that vertical bar. Now I want to do that when x is -3, when x is 0, and when x is 9. So I'm doing 3 different problems here, basically. So when x equals -3, that's -3. So that first one is -3. The second one, again, I'm just going to scroll up and highlight and then enter. I'm going to change that -3 to a 0. So delete 0. So -1. And then same thing, scroll up and highlight and then delete 9. So 5. H of 9 equals 5. So I didn't write this one out this time. Hopefully you understood. Again, all I'm doing is I'm plugging in these numbers for x. They're asking me to evaluate this function right here when x is -3, 0, and 9. What I think is really important is that you understand that this is an x value and this is a y value. So you could potentially be asked to plot those points. It's really important that you understand that. So in a different color here, I'm going to just write out that these represent ordered pairs. So this would be the x, this would be the y. So this would be -3, -3. This would be the x, and this would be a y. So 0, -1. And same thing, this is an x, this is a y. So 9, 5. So essentially, when I get these points, I could then graph each one of these, and I could make a line, because this is a line. Hopefully you know that this is a line. So you could just plot points, those points to get that line. So that's really important that you understand that. Okay. All right, number 4. So this time we have x squared minus x. So we have 2 places where we're going to have to plug this in. We have an x here and we have an x here. So we're going to plug this -4 in right here and right here. At this point, these parentheses that when we plug in are really important. And so I'll show you why that's so important. Okay. All right, so I'm going to open a new document. So we're plugging in -4. This -4 right here and right here. And every time I plug it in, if I'm just typing it in my calculator, I'm going to put it in parentheses. So I'll show you why that's important. So we would have parentheses -4 squared minus, in parentheses, -4. So for a couple of reasons right here, -4 squared means -4 times -4, which hopefully you know a negative times a negative is a positive. So if I type it in with parentheses, -4 squared, that works. If I don't put the parentheses, let's say I just put -4 squared because I'm lazy and I don't put those parentheses, my calculator tells me it's -16 when we know that a -4 times a -4 is a +16. So essentially what your calculator is doing right here, it does 4 squared and then it multiplies by a -1 right there in the front. So it's doing this operation. When you type it in without parentheses, this is what your calculator thinks you're doing, which would give you -16. Okay. Another reason those parentheses are important is because right here you have a minus and then we plug in a -4. So a lot of students will forget to put this negative because they put that one. You need both of them. You need the one that was from the equation and the one that goes with the x. You need that one too. So I would just type it all in at one time. So either like this, parentheses -4 squared minus parentheses -4, like that is one option. The other option is to use the other ways I showed you. So we could type in x squared minus x and then do control equals to get that vertical bar, and we want to evaluate that. So basically that vertical bar is saying evaluate that when x equals -4. So I want to know, what does x squared minus x equal when x is -4? And that gives me 20. So same thing when I type it in that way. Okay. So -20 is that one. Again, using my calculator, I would just scroll up and highlight this. So I want to now know what is x squared minus x when x is -1. So I'm going to delete that 4, change it to a 1. So when x is -1, it is 2. And the last one, I want to know what is x squared minus x when x equals 7. So positive 7. It is 42. All right, so let's look at, we have a word problem and then we have a graph, so a little bit different. So number 5 says, anthropologists use the length of certain bones of human skeleton to estimate the height of the living person. One of these bones is the femur, so that's one of your legs in your, or the bones in your leg, okay? To estimate the height in centimeters of a female with a femur length of x, the function h of x equals 61 and 41/100 plus 2.32 times x can be used. So find h of 46. So a lot of words there, but essentially it's just asking us to do the same thing. It wants to know, what does this equal when x is 46, right? This was h, what's an h of x. So that x is now a 46, so we're going to take that 46 and we're going to plug it in for this x right here. So if I were writing that out, it would look like 61 and 41/100 plus 2 and 32/100 times 46. Right, I plug it in parentheses. So you could type it in exactly like that. That's one option. The other option is to use that other method that I was showing you. So if I'm typing this in, again, 2 ways. So new document, add a calculator. So I would do 61 and 41/100 plus 2 and 32/100 times, let's scoot this over, times 46. Whoops, I forgot my parentheses. Times 46. So 168.13, okay, or 168 and 13/100. Or we could type in 61 and 41/100 plus 2 and 32/100 x. We want to know, what does that equal when we evaluate it for 46? Oh, I forgot to put x equals right there. So that's pretty common. Students will mistype it, and there is me doing that perfectly for you. So x equals 46, when x equals 46. So make sure right here you put x equals, otherwise you'll get error. There we go, 168.13 or 168 and 13/100. So it says that we estimated the height. So h of x equals 168.13. So h of 46 equals 168 and 13/100 centimeters. So the next question, really important, it says, so what does this mean? What does that mean? So that means if a female's femur is 46 centimeters, which is really hard in my mind to estimate, but maybe you're better at that, 46 centimeters, then she is 168 and 13/100 centimeters tall. So maybe it would have been better to put this in inches so we could at least figure out how tall that really is, but that's what that means. So we're going to kind of abbreviate that in my writing here. So a female with a femur of 46 centimeters should be approximately, so I'm going to put these little squiggly, that means approximately 168 and 13/100 centimeters tall. Again, we don't typically use centimeters to discuss height of humans, but that's what they did here. Okay. All right, last example, number 6. It says, given the graph of the function f of x, find each of the following. So they're wanting us to find f of -4, f of 0, f of 2, and f of 5. This time we were just given a graph. We don't have an equation, so you can't really use your calculator because we don't have an equation to type in. So this is when knowing what this means is important. So up here it was f of x. So this is f of x. These are x values. -4x, a 0 for an x, a 2 for an x, and a 5 for an x. So every one of those is an x value. So all they're asking is when x is -4, what is y? So when I go to where x is -4, so I'm looking at my x-axis, that's this one, the x-axis. I'm going to go to -4, so -1, 2, 3, 4. When you put a point on the line right there at -4, the y value is 2. So f of -4 is 2. So I got 2 by just counting up. 1, 2, right there. Okay. F of 0. So same thing. We go to where x is 0, right? This is x. So x is 0 at the same place y is 0, right there. 0, 0. So that is 0, 0. That would be a coordinate on that graph. Okay. Same thing on the third one. Our x is 2. So the question is, what is y? So when I go to where x is 1, 2, so 2 to the right, you go down to the graph right there. So that would be -1, 2, -2. And then last one, D, it wants to know when x is 5, what is y? So I go to where x is 5. So 1, 2, 3, 4, 5. Go down to the actual graph right there. That would be -1 because we went down 1 on the y. So you should be able to identify each of those as a coordinate. So A, that's -1, 2, 3, 4, 2. B, 0, 0. C is at 2, -2. And D is at 5, -1.